going to turn off view wireframe. And we can see we get something. The first thing I'm going to do is I'm going to fix this world out here so that it's not shining this blue light on everything. This should look white. To do that, we're going to go in here and set the strength of the world's emission to 0. It'll of course turn black because there's no light, but then we're going to go in here to the material properties, hit A, press the keyboard period, sort of zoom in on this. And then what I'm going to do is I'm going to bring this down to the emission, and that'll give us some light here, but there's still a few problems. So I'm going to come here into the render tab. I'm obviously in Eevee. I'm actually going to go over to cycles. I'm not going to turn on denoising for this, but I am going to reduce the samples down to 16. We don't need too much detail here. We're going to go down here to film. We'll set it to transparent, but I'm also going to come over here to the color management, and we're going to go from filmic to standard. And that way things will show up more or less the way it's supposed to. The next thing I'll do is I'll come over here and use shift right click, and I'm actually going to add a gamma node, and I'm going to set the value to 2.2. The reason it works has to do with the way color information is displayed. I don't really want to go into it right now, but just understand that'll help with this. So now we need to figure out why we have these black patches, and the answer is simple. Right now, these values here are less than 1. The difference between -1 and -0.9, -0.8, they're all showing up as black. What we need to do is to remap this. So we're going to go back to geometry nodes, and then we're going to add in a map range node. As I mentioned in the video, we're going to need to nail down the minimum and maximum values here. And as you change them, you're going to either hide or obscure these things. Like if you look at this part here, you can see I'm sort of cutting through this little value here, meaning all of this is going to show up as black, which shows up as a black patch right here. There is data there, but we lose it. So we do need to make some sort of tuning to this, but it's a little bit organic. And personally, I like to come in here and use the map range node to set this. And here's the two values I'm going to tune here. So I'll set up a value node. Name it map range. I'll set this here, and I'll set it here as well, but I'm going to put in a math node where I'll multiply it by -1, minimize that, and shove that in there. And now I can set this to whatever I want, and we get the result here. I'm going to set this a little higher, and that looks fine for right now. And what we've got now is a situation where we can take a look at the values we've got and see what went wrong. And I promise I did not plan this mistake. I actually don't know what it is right now, but I do get to show off what I did here. So yay, I think. I'm going to look at the other lerps. That one looks fine. That one looks fine. I'm noticing something though, and that is that this is smoothing across in the Y direction, and it doesn't seem to be smoothing across in the X direction here. I'm not really seeing any more smoothing here. It looks like it's doing something with the Y direction again. So maybe that's it, but it looks like I'm drawing the X value here. Let's see if this is what I think it is. So if we look at the smoothed values, that's smoothing in the X direction there. That's smoothing in the Y direction there. Now I'll bring the actual vector to see them both at the same time into the debug vector slot here. And then I'll come out here and actually add in a reroute node here and put this into the coloration slot to see what it looks like. As you can see, the 0-ish area over here and the 1-ish area over here are pretty well spread out. And so we have a nice gradient here. Most of the change is happening through this band here, and this band here, and this band here, and this band here. So what this tells me is that it's smoothing correctly. So let's head in here and look at the other vectors. So like for example, if I plug in the offset vector here, let me plug in a length value here. Right, so because the debug vector doesn't have a map range node going through all three elements, it was going to show up black. However, what I did, went in here, and I simply put a length node here, and now I can look at this, and you can sort of see this should be upper left, this should be lower left, and this should be lower right. Okay, so that's looking pretty good. Now these dot product maps really ought to look like the 4 maps that we saw during the video. You can see this is what I was dealing with. And if I replace it, I get the map over there, I get the map over there, and I get that map. So those are the 4 different maps. Now if I come down here to the attributes one, connect this back up, there we go. What you'll notice is that these are solid colors, and that's what we would expect. This solid color is an X and Y value that have been turned into an RGB value, and that should stay the same throughout the whole cell. That's because this whole cell is looking at the one value here, which is the upper right. If I look at the upper left, you'll notice the whole thing seems to shift over some. And if I look at the lower left, it'll shift up. And if I look at the lower right, it'll shift back. Okay, so that looks good to me. Okay, so I don't know what's wrong, so I'm going to pause here for a second and try to figure it out on my own. Okay, so in trying to figure out what's going on here, I noticed that the Y lerping looks fine, but when I go and add in the X lerping, basically not doing it properly. So in order to suss that out, I just recreated the node network, but this time I'm doing it horizontally and then vertically. And of course that paid off because I can now see the horizontal smoothing is not working at all, either there or there. So I don't know. Let's see if we can't figure out what else could be happening. I've been doing this for so long. The good news is this debugger is very handy. The bad news is I haven't quite figured out how to make it all work right. I've added a length node here so I can just see some details. So if I, for example, go in here and hook up the length to the debug float, head back out here. Oh yeah, I set this map range thing up. All three of these outputs get pumped through these three map ranges, which all let me tune things exactly how I might like. I set up a vector one so I can actually have it go from the right minimum and maximum to 0 to 1, but often I don't use it only because it tends to make the colors look all funky. Anyways, if I hook up the debug float, which comes down here through that map range, I get this, and I can see that I'm looking at one corner up here. Good visualization tool would do again. So this is going kind of fast, but I'm just tinkering here, and this is kind of what the purpose of this is to actually look at the data. I know that GeoNodes has a spreadsheet, and you can kind of look at the data that way, but that's not so useful because most of this stuff is being shaded within the shader graph. If you look at the shader graph, hit A, press period, so I zoom over here, you'll notice that it's going through this attribute. So basically when it wants a base color, it's going backwards and going to this reroute node, through the gamma node, to the attribute node. It's going to go look for that attribute. Then if I go back to the GeoNodes, which is supplying the attribute there, it's going to go back through here, go through that map range, go through the whole Perlin noise thing, and eventually at bottom, it's going to get to this position node here. And that position is where the actual color is happening. Well, that's really good, but that does mean that when I go to make an actual spreadsheet, all I'm going to really see are the attribute values at these corners. That data isn't necessarily living on a vertex, it's just something that is summoned into existence when that calculation is performed. The other things I've created, I made the spaghetti a little less spaghetti, although it's still kind of delicious spaghetti. I've gone through a fine-tooth comb and I looked at every single little detail here that I could find, and everything looks great. Wait. No, this is backwards. Okay. Well, that's definitely something that needed fixing. Oh my God, that fixed it. Wait a second. Hang on. Do we have victory? Hey, look at that. Is this the same? Yes. Okay. All right. What a nightmare. Such a good justification for having this debugging stuff in here. But anyways, that's that. Let's move on. You know what? We're just going to go ahead and save. So let's go ahead and set this up for the next steps. We're going to need 4 octaves. Of course, you can do as many as you like, but I'm doing 4. All right, so I'm going to come in here, grab all this. I tend to deselect my frames when I move stuff around just so it doesn't snap the frame. I'd rather have the actual nodes snapped. When it does this, I hit Control Z. If I click on something inside of the frame, it makes the whole thing that. If I click on something outside the frame, it doesn't. So at any rate, we're going to go ahead and move this out even further because we're going to need a whole bunch of room. So let's go ahead and sever these connections. We should be able to just remember that these 3 nodes kind of match up with these 3 here. And so let's go ahead and make some more of these. There we go. Now I'm just going to come in here and set these. So this is going to be octave 2. All right, so now let's go ahead and hook this up. I'm going to move these up a bit. I'm going to have to bring these out because I'm going to need them a few times. So I'm just going to duplicate these out. All right, now that it's all connected up, I tend to try to move this stuff out here so I can see the noodles more easily and try to make it look similar to this. Now I know I need to bring these things out here. So I'm going to be using the actual base mesh that we made for all of these. The reason is that inside of these octave calculations, we're essentially processing the data as if it came from that fresh, pristine mesh. Okay, next thing up, we got to set up our outputs so that we can actually do something with this. So again, I'm going to bring these out into reroute nodes. So the way it's going to work is I'm going to have the 4 Perlin noise views coming out here, and I'm going to have the debug stuff coming down here. Let me go ahead and label things up. One little trick I do is if I see that noodles are going to obscure the title of something, I'll come in here, I'll hit F2, and I'll put in some leading spaces. You don't have to do that, but it's just a little life hack. There we go. The next thing we need to work out is how to combine the octaves. The good news is this is pretty straightforward. So let's go ahead and again move this stuff out further. Before we do this, let's just take a quick look and make sure that the octaves are what we think they should be. That looks good. Here we go. That looks good. That looks good. And that looks good too. So what we're going to do is we're going to make a geonodes network that's going to take as an input one of these octaves. Then we're going to also give it the persistence, and we're going to tell it what the octave is, and it's just going to combine it in there. It's going to be pretty straightforward. Let's go ahead and just make a math node. Going to make this a network. So now I've got 2 values coming in. We also want to add in something for the persistence and what octave it is. So just as a little bit of mathematical detail, the persistence is generally less than 1. And what you do is for each successive octave, you multiply the values of that octave by the persistence raised to that power. So what that means is I'm going to bring a power node out here. The base is going to be the persistence. And it's not going to be the octave, again, because it's going to... My cat is meowing at me. And again, it's not going to be the octave, but rather the octave minus 1. So there's subtract 1. So the exponent is going to be the octave minus 1. We'll scoot that in there. Then we'll just reroute this a little bit. So now this is going to be our multiplier, and what we need to do is multiply. So this should take the octave, subtract 1, raise it as the exponent to the base being the persistence. That gives us a multiplier. Then we simply multiply the next octave by that value, and then output the whole thing. So let's come back out. We're going to go ahead and call this combine octave. So then what we're going to do, we'll start with the first octave here, the second octave right there. The persistence is all the way down here. It's this gray noodle here. So we're going to bring that in. All right, so this is our persistence. So I'm just going to bring the values. Remember, these are just values. And I'm going to bring them down on some noodles. There we go, good enough. So we have our 3 octaves here. The bottom one is octave 2, middle one is octave 3, farthest one is octave 4. So the octave we're adding in is octave 2. So we have our persistence. And as we just said, our octave 2 is the bottom one. So we're just going to duplicate this a few times. Now we simply need to bring in the other octaves. So let's see if this spaghetti is delicious or undelicious. We actually need to give it a persistence value. Let's say 0.5. And hey, that looks pretty delicious to me. I will show you how to make this look bumpy, but that actually is pretty straightforward. The simplest way to explain it is I'm simply going to displace this mesh, and I'm going to use the subdivided version of this. Now, the thing is that in order to come up with this 4th octave here, I had to make 3 subdivisions. So I just want to keep that in mind as I put in a value for subdivisions here. If this is less than 3, I'm probably going to run into some sort of trouble. Essentially, it's not going to have enough geometry to put bumps where the shading would otherwise suggest. So in order to do that, I'm simply going to come in here and I'm going to add in some displacement stuff here. So let's go ahead and move this back here. In order to do this, we're going to do a set position node. In order to make this work, we're going to need to offset these things. And in order to know how far to offset it, we're going to need the values coming out of this map range node. So let's go ahead and move all this over here. We're going to take this value, treat it like a z coordinate in a combine node. And what we're going to do is we're going to add this to the current position vector. Then we're simply going to add these together. And the way I did that was I held Shift and Control and right-click dragged, and that gives you an add node. And so what we're going to do is use the result of this addition node as the actual position. There's a reason that I moved this over so that this corner was in the origin, and it's so I could pull this little stunt. But what you can see is that you now have Perlin noise as a sheet. So the rest of the video is going to feel a lot less like a math lesson and more like your normal Blender tutorial. And that's because we're going to take this Perlin noise sheet and we're going to make it look like that nice art thing I had at the very end of the video. So let's go ahead and put some frames around things. And there we go. I'm going to use a shader to give me that sort of terrain look with the blue water and green fields and all that stuff. I'm going to do this in 2 steps. 1, I'm going to fix the nodes up, and 2, I'm going to change the way the environment is rendered. So to fix the nodes, we'll start with this node. So this is what I used in my actual video. If you wanted to make your own, all you have to do is add a color ramp node. I like to make it longer just so I can actually see what I'm doing as I put these little pieces in here and twiddle with them. If you want to add these things in here, all you have to do is click the plus, come down here, click on the color, and you can change it to whatever you want to be. So that's perfect. But anyways, this is what I picked when I got done with that process. The key insight is this factor socket right here. This goes from 0 to 1, and you can see that 0.5 is right about halfway in between. This is essentially a mapping from 0 to 1 to this color range up here. So if you put in 0, you'll get blue. If you put in 0.5, you'll get about this green here. If you put in 0.75, you'll get to about right here. If you put in 1, you'll get out here. The way we're going to use this is we're going to plug the output of this Perlin noise, which is giving us these dark and light colors here, and use that to guide the factor. So let's go ahead and put this in. So we're going to move this right there. What I did was I simply dragged on top of the noodle and it connected it up automatically. You'll notice it looks really weird, and that's because we still have something going into the emission, and so let's go ahead and just fix that really quick. I'm going to cut this. It's going to turn black because there's no light in the scene and it's no longer emitting any light. Then I'm going to go over here to the world tab, and normally I could add in this blue color, but as you see, that blue is tinting all of this. So instead, what I'm going to do is I'm going to use what's called an HDRI. If you're not too familiar with HDRIs, I'll leave a link in the description below for a tutorial on them, and I'll also leave a link to a place where you can find free ones at Polyhaven. So in order to do this, I'll stay in the shader editor, but I'm going to go to world mode, select the background node, and because I have Node Wrangler installed, I'm going to press Ctrl T, and boom, we have all of this stuff set up. Now right now there's no picture in here, which is why it's shining purple on this thing. And what I'll do now is I'll just import an HDRI. Now I have this image coming in, and you can see it's blown out white, and that's because I tuned the strength up to 14. Let's just set that to 1. Much more reasonable. If this is something you're doing for an art project, there's more you can do here, but for right now, we'll just roll with this. Let's head back to object mode in the shader window. And what you can see is that the high spots are indeed white and the low spots are indeed blue. This is almost what we want, but right now the world has this sort of reflectiveness that makes it look almost plasticky. I'm going to show you a little bit of how to tinker with this, but I'm not going to spend too much time on it. This is the art portion of things, and I'm more trying to show you the technical how-to bit and let you work out how you're going to tune the knobs so it looks good in whatever you do. So what I'm going to do is I'm going to use the color ramp to influence the metallic and the roughness sockets. To do this, I'll simply duplicate this. And I'm going to set this up so that the water is reflective, the snow is kind of reflective, but the rest of the terrain remains matte. In order to do that, I'm essentially going to treat this like a mask. I'll bring the color down here to the factor, and I'm going to take that, and just so we can see it, I'm going to put the color in the base color here. I'm going to use this to set the metallic to 1 in certain areas, making it very reflective, and then set the roughness to 0 in those areas so that it looks like this. Right now, this is essentially incredibly metallic and reflective. We would never actually use this. But for the water, this may be exactly what we want. So to do that, let's undo the edits to the metallic and roughness. And what we're going to do is have these various color ranges be either black or white. I would like the metallic to be turned on in the water, and so I'm going to set this water to being white. That is to say, 1. Because this is going to be taking more time to render, and set this to material preview, and now my edits become a lot more snappier. So I'm going to turn this white, and then I'm going to take the saturation all the way down. I'll do the same thing here. And then I want the sand and grass and forest and rock and all that, whatever these colors are, to essentially have no metallic values, and so I want them to be black. And so what I'm going to do is I'm going to get rid of the ones that I don't need anymore. by clicking on this minus here. And now I'm going to set this to black, as well as this one too. So as you can see here, the map shows that the valleys, the water, is going to be white and reflective, as are the snow caps. But I don't want the snow caps to be quite this white and reflective. We're going to bring this down just a bit. So I'm going to come here and I'm going to set this to, say, a gray. That looks good. Now that I'm done visualizing this, I'm going to plug this into the metallic socket, and then I'm going to plug the color back in. And now let's take a look at the render preview. And there you go. Although I'll admit, it's a little hard to tell. And the reason is because it's still very rough. So what I'm going to do is I'm going to set the water and the snow to not be rough at all, and everything else to be very rough. That's essentially the inverse of this map here. And handily, there's an invert node. So I'll bring this in, take the color, plug it into the color, plug this into the roughness, and now you can see this becomes very reflective, and the white here is as well, but you can't really see because there's not much reflecting off it right now. So that'll wrap up the shader bit. Let's go back to the geonodes and we'll make this water nice and flat. The way we're going to do that is by messing with the displacement. So let me give myself a little bit of room here. Because I'm going to be messing with items in this frame and the frame is just going to be extending and going all over the place, I'm just going to temporarily delete it by clicking on it, pressing X. This part isn't going to change. We're essentially going to continue adding something to this position here and setting our position here in the set position node. What's going to change is what's going on over here. What we're going to do is we're going to make another mask. And what that mask is going to say is anything below a certain point here, make it flat. So the way we'll do this is we're going to zoom in on this thing here. There we go. Swap over to material preview. Now things will be nice and snappy. What we would like to do is we're going to create a second vector that's essentially going to flatten this thing out at a certain level. So let's make a second vector, which in this case I'm just going to use a combine node for. And what we're going to do is we're going to use this Z value, but we're going to filter out everything past a certain value. The way we'll do that is with a math node. Put it in here, and we're going to set this to less than. Now, so we can see our edits, we'll plug this in. And it's terrible. What's happening is that the less than node is outputting either 1 or 0, depending on if the value is above or below this threshold. If this value is less than this threshold, it's outputting 1. So if I wanted to reduce this down to just this lake, I'll zoom in on it by essentially lowering the threshold. That looks like it's pretty close. However, we want to use this as a mask. The way we use that mask is in a mix RGB node. So I'll add that in. And now what I'll do is I'll plug in the value here to the factor node. There. Now this is using it essentially as a mask. Where it's 0, it's going to give me this first color, and where it's 1, it'll give me the second color. But remember what a color is. It's 3 values, just like X, Y, and Z. And so what I'm going to do is I'm going to plug in this vector into this color, and then I'm going to plug this color like a vector into here so we can visualize it. Now you can see something crazy is happening about right here. The reason it's crazy is because it's getting this right here, and if we wanted to look at what that was, we can go over here to the hex, and this is essentially close to 1 right here, which means it's adding about 1-ish to the position value. And that's not what we want. Instead, what we want is this. Well, now it's closer, but we don't want it all the way up here. We want it to be a nice smooth value here. How do we do that? Well, the answer is we actually want this height to be the same as this threshold here. So what I'll do is I'll put in a value. I'll copy the value here to over here. Then I'll plug this into the threshold. And then instead of putting in 1 for the offset, which is what's coming out of the less than node here, I'm going to put in the value into the Z height. And if I zoom in, it looks perfect. Part of the reason this worked is because of the map range node here. Remember, its output goes from 0 to 1, which this is between, which also works perfectly in the shader node where we need this factor to go from 0 to 1. Let's tidy up real quick. So that almost wraps it up. The only other detail I'll add is if you wanted to animate this. What I'll do is I'll bring up the timeline here. I'll set my playhead to 0, and then I'll right-click on the value and say Insert Keyframe. Then I'm going to click on this little thing here. It's a little hard to see, but it brings this thing out here. I'll open up the summary and then select the object, and then I'll select the node, and we should see this keyframe here. Then I'll take this keyframe and set it out 40 frames, and I'm going to come in here and I'm going to set this to 0. Now it shows up orange, which you can think of as a temporary value that you need to set as a keyframe if you want to keep it. And so we'll right click on it, insert keyframe, and boom. Now you can see it rises. All I did in my video was raise that up. You'll also notice that you see some of these jagged edges here. The way you clean that up is with more subdivisions, but it's going to become processor intensive at that point, and in the video I did, but here I'm not going to bother. And that wraps up this tutorial series. You should be able to take the building blocks of what I showed you here and make any kind of map that you wish, and with clever use of keyframes, you can make any kind of animation that you want. If you liked it, then please let me know, because I'm very seriously considering doing a Blender tutorial series for educators of technical fields. So if that's something you want to see, let me know. Either way, congratulations on making it to the next term in your Taylor expansion. I'm Derek Taylor, and I'll see you in the next one.
Thanks for watching. If you like this video, please click like and subscribe. If you really like the video, come on over to our Patreon page where you can get involved and see all the cool stuff we're doing.